I'm just first giving you the definition. Monotonic functions. So the definition is a function if from R to R, this is basically real line I'm taking, is said to be monotonic if either it is increasing or decreasing on R. It means, monotonic means the function, if it is totally like, if it is completely increasing or decreasing, then only we say that the function is monotonic. Now another definition is a function, this is monotonic definition. Now next definition is a function is said to be increasing, and a function I'm taking from R to R. It can be another like interval also, interval like AB or this interval. You know the difference now between these two intervals. This is closed interval, A and B are included. This is open interval. So I am talking in general right now. Monotonic means either the function is increasing or decreasing. In both the cases you will say that the function is monotonic. Now the what does this mean? Increasing mean. Okay, so increasing means a function is said to be increasing if for all values x1, x2 belonging to R such that x1 less than x2 implies f of x1 less than equal to x2. Okay, because we have two definitions, so please make it a point, just write down, then I'll clear. Next definition is, on parallel lines we'll write down, a function is said to be decreasing if for all, this also has meaning, it should be true for all values. It should not be that that you got two values where this inequality is not holding, then you cannot say that the function is increasing. In that case the function will not be monotonic. Okay, so we have to check for all points in that interval. If it is R, we'll check for all values of R. If it is this interval, we'll check in for all points in this interval. If it is whatever interval you are given, you will check on each point. Okay, and you take points in pairs. You take points in pairs to check increasing and decreasing behavior of the function. This is also at one point you are not checking, na? So the thing is, you take points in pairs from the interval. So the function is said to be decreasing if for all x1 and it means what? Order preserve. Increasing functions preserve the order. You agree? They are preserving the order, na? This is less than, here also less than equal to. So increasing functions preserve the order, and decreasing functions, what they do? Yes, they reverse the order. So for all x1, x2 belonging to R such that x1 is less than x2, this implies fx1 greater than equal to f of x2. Is it fine? So what basically it means? Two more definitions I'll write, and then one by one I'll explain you. This is basically definition of increasing function. Now I'm giving you definition of strictly increasing. What is the difference? So a function is said to be strictly increasing if for all x1, x2 in R such that x1 is less than x2 implies f of x1 is strictly less than, equality sign will not come. Okay, for all the points you will not get that images are same. For no 2 points you will get this. Okay, if you are getting equality sign you will say it is increasing, but if for all the points and points are such that x1 less than x2 you are getting f of x1 image also strictly less than, then you will say that is strictly increasing. Okay, so this function has different properties, this function has different properties. This is important one, this is important one, this one. If equality is coming, then some of the properties like it lacks. So this is important one. And how it is important one, when we'll do the questions you will get to know. So write down the definition on parallel lines. For the strictly, this is increasing, this is increasing, strictly increasing. So for strictly decreasing, what will be the definition? x1 less than x2 will imply greater than f of x2. Okay, so just quickly write it down. So strictly decreasing means x1 less than x2 will imply, it will reverse the order, that's it. If I say for strictly decreasing, you just write down the definition first. Done? One by one I'll explain. Monotonic means it is either increasing or decreasing. So I'm drawing small graphs. Now what about this function now? What about this function? How we check? This is 1 point, this is second point, this point, any point actually I'm taking. So x2 is greater than x1 now. x2 image is where? This is x2 image, and you can see x2 image is f of x2 clearly greater than f of x1. I rub the definitions if you are like okay with the definitions. I just give the examples only now. Okay, now consider first example. This example, very straight, actually straight line I'm checking. So I want to know whether this function is increasing or decreasing. Suppose this is the interval from here to here. This is x-axis, this is y-axis. So this is here a 0, or this here suppose some 0.4. So see, 0 is less than 4. 0 is less than 4. F of 0. I'm not giving you function equation, I'm not giving you, but from the graph it is very clear, you can answer me. F of 0 is 0. Okay, F of 4 is bigger than F of 0, all agree? You now take any point here on this axis, because we take interval on we choose our domain on this line only. This for your like syllabus, we always take the domain from this line. Okay, so we have to choose points on this line only. Take any 2 points, any 2 points. So you agree that if you are taking any 2 points and the bigger point has bigger image, bigger point has bigger image in this case, so this function is increasing. Yes, I explain you that also. But the thing is here, no equality sign will come. If you are taking 2 points, one is bigger than the other, then equality is not coming. It means for 2 distinct points, image is not coinciding. You can see, not coinciding now. So equality sign will not come for this function. You cannot give me 2 points, 2 different points where the function value is coinciding. You are not getting into values. You can see 0, 1 distinct values. It is increasing, but images are not coinciding for 2 distinct points. So in this case, for all x1, x2 belonging to some interval, f of x1 is strictly f of x2. Strictly. So this function is increasing but strictly increasing. Okay, strictly increasing. Now the thing is, if I just draw the graph like this, What about this function now? What about this function? I just make it little clear. What about this function? Increasing or strictly increasing? Because here you see for two distinct points image might be equal. Okay, it is clear from the graph. This is strictly 1, this is not strictly, but it is increasing. All agree? Somewhere it is decreasing. Somewhere it is decreasing. Nowhere. From the graph it is clear. But now I am showing you everything by the graph. Everything by the graph. But it is not possible now that every time you can draw the graph of the function. It is not possible always. So how you will do that? I think before that, just let me give you another example. What about this function now? This is strictly decreasing. Okay, because you are taking here any point here. This is x1, this is x2. So x1 is less than x2, but f of x1 is this. This is bigger, and f of x2 is this. This is. So this time, this is not keeping the order. This function is not keeping the order, not preserving the order. So this function is, sorry. In either of the way we can write, this way we can write, or this way we can write. So this function is decreasing. What about now this function? Okay, this function is monotonic. This function is monotonic. This function is monotonic because either it should be increasing or decreasing. In both the case we say monotonic. Now what about this function? It is decreasing. Okay, so now it is clear to you. I have the board. What about now very familiar or very, I think you are used to of this question. What about this question now? Y is equal to x square graph is this. Okay. Now, what about mod x function? You all know. Okay. This is mod x function. What about mod x function now? Is this monotonic? Is this monotonic? Why? Yes, because here it is decreasing. In this minus infinity to 0 interval it is decreasing. It is decreasing, and in this interval 0 to infinity it is increasing. So we cannot say, because complete behavior should be like either increasing or decreasing. It should not be like increasing or both it should not be. So but I can say mod x is strictly increasing on 0 to infinity. You agree? In this interval I can say, and I can break it. So mod x is strictly decreasing. Okay. So now the thing is, here it is decreasing, here it is increasing. By the graph only it is clear. Now please listen, one more important thing. If I ask you for on the same basis, when I'll do the questions, but I want to discuss it right now. If you see, like from this increasing decreasing behavior now, we can check where the function will vanish and how many times. Where the function will vanish means fx equal to 0 will be how many times. Okay, so using this increasing decreasing function we can check it. Fine. So if you see here, this function is decreasing. Here this function is increasing. So using this behavior, you can answer like how many times, or like one time, at least one time you can answer that it will vanish. Okay, at least one time. When so this is one application. Using decreasing behavior, you can check how many times the function will vanish, or vanish means fx equal to 0, and fx equal to 0 means what? You will get the roots. You will get the roots of that function. You are getting the roots now by using increasing decreasing behavior. So this is one application. Now one more thing is, if you know the function is increasing in an interval, okay, in an interval, okay, here also the same situation. Same situation, in half interval it is decreasing and in half it is increasing. So this is also not monotonic, but here it is monotonic in half interval, and in this half interval it is monotonic. So now if you know f is strictly increasing on any interval, okay, strictly increasing, it means this, suppose I just take the interval, it means in this interval this function is increasing, strictly increasing I am taking. Actually strictly helps. Suppose this is the function, any function. This is increasing. So a value is here, b value is in this interval I am saying na. So it means this is the least value of the function. This is the least value. All agree? Because, and this is the maximum value. Using increasing decreasing function, if we know that our function is strictly increasing, we can answer maximum and minimum point. Maximum and minimum point. So this will be the minimum point fa. Fa is the least value. Fa is the least value. This is another application now. Okay. And fb is the maximum value. I hope these things are clear. Now let me move to the theoretical definition. How we find out the behavior of any function using that definition. Side up the board. Maximum minima you have done. You have in school you have done. So there you have used, I think, different definition. You find critical points and then you see double derivative method and first derivative method you have used. But if you have strictly increasing function, no need to apply any method. No need to apply any method. This value will be the least, this value will be the maximum value. But that method helps for, in general, for all functions. Okay, that method helps for all functions. But if you know your function is strictly increasing or strictly decreasing, you easily can answer maximum and minimum of that function. So now come to the definition, write down theoretical definition, how we'll check. For increasing a function which is differentiable in an interval I, I'm taking it I, okay, I'm not specifying it. If in an interval I is said to be increasing if f dash x greater than 0 for all x and I. Okay, derivative should be greater than 0. Okay, derivative should be greater than 0. So this is the only definition now. We will find derivative and we will check on that interval if it is greater than 0. For all values, we will see it is increasing. Okay, fine. So now for decreasing, same on parallel lines you can write down a function which is differentiable is in an interval. Okay, differentiable it is. What about continuity? Continuous I'm not saying anything about, I'm not writing anything about continuity. It is continuous because differentiable. So I is said to be decreasing if f dash x is less than 0 for all x in I. Is it fine? So now take example e to the power x. What about this function now? F dash x will be, what about this function? Like what holds for this function? This is greater than 0, this is 0, or this is less than 0, or it has mixed behavior. Function can have mixed behavior, na? Less than 0, greater than 0. So in that case, so we have to partition the function, interval basically. Okay, then only we can say. But you know about this function. This is, no, this is exponential function. So what about this behavior of this function? It is, what you are saying? Ever increasing means? So value of this is always greater than 0. Always. It is never 0. Is there any value where it is 0? Never ever? Okay, tell me e to the power infinity is how much? E to the power minus infinity is how much? And then e to the power 0 you all know. E to the power x expansion, tell me. Then I think. This is the value, na? Last time I think I told you e to the power minus infinity value. And that is 0. Okay. So 0 it can, but minus infinity generally we never include in our interval. You know, na? We always write our interval in this form. So it means this point we never include. So there is no point. E to the power minus infinity is 0. But the thing is, on this point we never do discussion. We always take open interval, na? For infinity. Yes, excluded points, open interval we take. So e to the power minus infinity is 0, but we never take this point. So e to the power x for all values, this is the expansion, this is the series of e to the power x. This is always greater than 0 for all x in R. R is basically minus infinity to infinity. This is the interval, na? This is the interval, so this is positive. So it means what? It means what? E to the power x is? E to the power x is strictly increasing function. Okay. Now tell me, just write it down and then tell me. Now answer me this question. Which value is bigger? Which value is bigger now? Which value is bigger? Don't. I think how you are doing the calculation. In mind you are doing, or you are putting some property, or what you are using to answer this question. How you are checking it? Just answer me first. How you are checking that which value is greater? How you are checking right now? Where? Okay, you are putting pi value and then e value. Okay. How many of you are saying, because I don't know, which value is greater? How many of you are saying e to the power pi is greater? Okay. And what fact you are using? Pi is greater than e, and then any other surety point? Okay, e is positive number. Anyhow, your fact is okay, but I am using this. e to the power x, I said e to the power x is increasing function on R. It means if you have any two values, both are pi and e, both lie in this interval, na? Okay. So increasing means if you have two values, pi is okay. Pi is how much? 3 point something. So pi is greater than e. All agree? E to the power x function fx equal to this is increasing function. So it will preserve the order. So f of pi will be, f of pi is how much? Now because if I ask you e to the power 1 upon pi, then e to the power 1 e square. Now you can check it, na? First you will check which number is bigger, then you can easily answer which number is bigger. Is it okay? So what fact I am using to know which number is greater or which number is smaller? Increasing, decreasing behavior. Is it fine or not? It is fine. So now you can check any value. Which one is greater, which one is smaller. So which fact you used basically? Increasing behavior of the exponential function basically. Is it fine? Which value is bigger, वैसे? I don't know. Tell me. Which value is bigger? E square will be how much? E is how much? 2.17. 2.17 something, it's like a big value. And then pi is how much? 3.14. So 1 upon any number will be less than, 1 upon any like positive number is always yes, less than 1. So this number is less than 1 and this is greater than 1. So e square is greater than 1 upon pi. So this number is bigger. So from here it is very clear. But if I put square root and some other, like if I make it difficult, then I think this increasing behavior will help. Is it fine? So increasing behavior you use to know which number is greater. Okay, now come to some of the properties. And properties are like, okay, one note. A note is like, if f is increasing or decreasing, you can say. If f is increasing or decreasing, what can you say about derivative? My point is, about derivative means increasing or decreasing behavior. Can you answer? Suppose your function is increasing. So can you say your derivative will be increasing or decreasing? Can you say that? No, you cannot say. Okay, so it is very clear, if your function is increasing, no idea for increasing and decreasing behavior of the derivative. But the surety is, if function is increasing, then okay, derivative will be positive, that is surety, but you cannot say increasing or decreasing behavior. Seeing this, that the function is, the derivative is greater than 0, you can say that the function is increasing or decreasing. Is it fine? Now, but if you know for the same function this, now what can you say? If you know double derivative of that function, same function is greater than 0, now what can you say about derivative? It is? Now you can say now. How many got to know? Is this okay? So this is very clear now. If f is increasing, f dash is positive. If f double dash is positive, this implies f dash is strictly increasing. If triple derivative is positive, then second derivative will be increasing. Okay, it means if suppose this is strictly increasing now, this function, please see here, suppose I am taking here any interval, it means what now? F double dash is positive, so what? Graph, derivative graph first, so you should know the uh, function. Take any graph, okay, x to the power 4, then it will be 4x cube. This is basically x to the power 4 function derivative. Now it will depend on the interval. First you find out the interval where the function is increasing. So where this function is increasing? Negative side. Negative side it is increasing. So break it. For minus infinity to 0 values, it will be, this is f dash x. This is less than 0 now in this interval. This is less than 0. What about double derivative now? It will be 12x square, and this is always greater than 0. This is always greater than 0. So this is greater than 0, but our function is strictly so this is negative for these values. So this is, wait. This is minus 4. So this is basically minus 32 less than minus 4. So it is preserving the order. Yes, it is preserving the order. So this is increasing function. Okay, I got confused. So this is increasing function. F dash x is less than 0 in this interval, but anyhow the function is increasing. Minus 2 is less than minus 1. This is preserving the order. Okay, I think that property is anyhow not matching. F dash x is less than 0 for all x in minus infinity to minus 0, 0, but this function is increasing. F is, because it is preserving the order. It is preserving the order. In this interval, it is preserving the order. You can see minus 2 is less than minus 1, and f of minus 2 is also less than f of minus 1. So this function is increasing. Okay, now the thing is, what is basically happening? I just in definition what I wrote, if, please make it a point, necessary and sufficient conditions basically we add. If f is decreasing, this implies f dash x is less than 0, but sometimes it in reverse it doesn't go in reverse. Are you getting it? Because f dash x is less than 0, then here this problem for, especially for this function x to the power 4, this is always greater than 0, but this is negative actually. 4x cube is, so I should take This is positive. And for 0 to infinity, fx equal to x cube. This is again increasing for 0 to infinity. For all x belonging to 0 to infinity, there also it is increasing. There also it is increasing. But here the derivative and derivative is, for these points, derivative is positive. Yes.
Ma'am, you have taken there that minus infinity to 0 it is increasing. It should be 0 to infinity it is increasing. Minus infinity.
No, what happened? Minus 2 less than minus 1, all agree? Then f of minus 2. F of minus 2 will be how much? Minus 32, and this is less than, minus 4 is greater than minus 32, all agree? So it is preserving the order. Anyhow, derivative is less than 0. Derivative is 4x cube. So whichever number you put up in this interval, minus 2 if you put negative, minus like whatever you put. So this is, derivative is negative, but the thing is this function is increasing, in the behavior of this function is increasing, and 0 to infinity there is no problem, it is increasing. And for this interval especially, for this interval especially, if you take double derivative will be 12x square greater than 0. Okay, so this is also greater than 0. This implies this is greater than 0 for all x in. So behavior is increasing. Derivative behavior is increasing. So if this is derivative is greater than 0, function is coming to be increasing. But anyhow, this definition is not satisfying. Only this definition. Otherwise, fact is okay. Fact is okay if the double derivative is greater than 0, f dash is strictly increasing. That fact is not like anyhow violating. But the thing is, for this particular example which I have taken, this thing is not like satisfying. Because I in definition, but if you just make it a point, I think something we should add. I just gave you, if f is decreasing, then this will hold. In reverse order, I didn't say anything. If f is decreasing, then 100% you will get f dash x less than 0. Okay. But the thing is, यहाँ पे you can go in reverse, for especially for this example. Make it a point, please. Make it a point. It's a good example, I think we should discuss. But anyhow, some other properties we will add. Just write it down. I think something is, for this property we have to add. Reverse we are not going. What happened? Okay, I just tell you. What's your name? It's not mix up Rakhi. The thing is, for your syllabus, the definition is, if function is decreasing, derivative will be less than 0. If function is increasing, then derivative is less than 0. Anyhow, I didn't check this behavior of this function. I didn't check. But anyhow, this derivative is less than 0. On the basis of this, I can't go reverse. I can't go reverse. But the normal definition, if I am applying, normal definition is, take any 2 points. Take any 2 points, and images should be, function should preserve the order, and it is preserving actually. You see, my x1 less than x2, if you are taking, then in this interval, take any point here. Minus 2 is less than minus 1. Minus 2 is less than minus 1. So what you are getting basically? Okay, nobody noticed actually. What I was doing, this is the function minus infinity to minus 0. I took 2 points in this interval. Okay, I took 2 points. Now function is this, na? I was putting the value in the derivative. I was putting the value in the derivative. So minus 2 is less than minus 1. So f of minus 2 and f of minus will be what? This will be 32. This will be 1. So this is not preserving the order. Is it fine? So f dash x less than 0 now it is fine. Okay, for this particular case we are getting it, but if you see necessary and sufficient conditions are there. So this is decreasing f dash x less than 0, and minus 2 less than minus 1, this is not preserving the order now, you can see. So this is for this interval, if you break it, minus infinity to 0 and 0 to infinity, here it is increasing, here it is decreasing, but the fact I am using is f double dash greater than 0 in both the cases. Now check, in both the cases the second derivative is how much for this function? It is 12x square. So in both the cases, for both the intervals it is greater than 0, but I took it like f dash is increasing, then derivative will be greater than 0. So if f dash is greater than 0, you say function is increasing. Now f double dash greater than 0, in case you are getting it, then I am saying it that f dash will be strictly increasing, but only on this interval. The problem is here only, and you know why it is? You know why it is? Because this complete function is totally is not monotonic. X to the power 4 on complete R, if we discuss, it is not monotonic completely. That is why this problem is occurring. It should be monotonic, then it will hold this property. In half interval it is decreasing, in half interval it is increasing. So what we are doing on that half interval, when we are talking, this is completely basically x to the power 4 interval. Complete x to the power 4 function is not monotonic. X to the power 4 function is not monotonic, so that is why this property is not holding for this function. In reverse, when we are going it is giving us contradictions. You can see for this interval minus infinity to minus infinity to 0, half it is decreasing, half it is increasing. But when I am taking second derivative in all the cases it is positive. It is contradicting my condition, because the very first function is not monotonic on the complete interval. Is it fine? So it should be on that interval. I have make it a point here. On that interval it should be completely monotonic. Okay, either increasing or decreasing, then only this property will hold. Otherwise it will not hold. So whenever we apply this property, we have to be very particular. On a non-monotonic function, if we will apply, we will get the contradiction. Is it fine? So now it is okay. So I think you can note it down. It's a good question. What happened? X to the power 4 function is not monotonic. So you make it a point. I just rub the board. And now as you asked, ma'am, how to think for f dash, f double dash, I think this is your point now. You are not able to think. Like if I am saying f is increasing, then if f dash is greater than 0, then it will be function will be increasing. Then for double dash I am talking about. The thing is that this function completely on that interval, it should be increasing. Then only it is possible. Okay. Otherwise we cannot talk. Now come to, is this okay? Any other question coming in your mind? It's a good question now. What about line? What about line? 2x, suppose I am taking this line. Okay, draw this line quickly. It is increasing. This line passes through region. This line passes through region. Draw. 0, comma. So it is basically when x is 0, y is 3. When y is 0, x is minus, okay, minus 1.5. No. Yes, minus, this is the line. Now I think I'll take this example. This is monotonic. Okay, I'll take this example. Double derivative is how much?
Single derivative is double
Okay, first I should ask, I should discuss first derivative. So 2, this is, now it is keeping the behavior. It is keeping the behavior because this is completely monotonic. There is no, it is not, this function is monotonic, so it is keeping the behavior. First derivative is positive, so f is. Now what about second? Now second onwards it is 0. So it is not greater than 0, so we cannot talk anything. After this we cannot talk anything. Is it fine? You can draw the derivative function now. You can draw f dash is 2. So what is the function? What function it is? Yes, constant function. This is the function now. And after this, no discussion because the derivative is 0. Either it should be greater than 0 or less than 0, then only we can discuss. Increasing, decreasing behavior, otherwise we cannot discuss. We cannot say anything. Yes, like increasing, decreasing, whatever properties we have, those are not sufficient. This is the point. Those are not sufficient to answer increasing, decreasing behavior for if your derivative is equal to 0. You have read inflection points. You have read inflection points now. So there where the second derivative is 0, inflection point topic comes, and from there like concave up and concave down, then this is how you talk about the behavior. Is it fine? So here we cannot discuss anything. We will stop here because this is derivative is 0. So we cannot discuss anything. What about now is this, if this function is monotonic, what is the least value? This function. What is the least value? What is the least value for this function? Least value, give me quickly. What is the least value? What will be the value now then? F of minus infinity. This will be the least value. Okay, I am not calculating it, and it will be 100% what? Minus infinity, and f infinity will be the infinity. So these are the upper and the lower values, maximum and minimum. You also know you can take it down till minus infinity. Okay, and derivative for derivative function both are same for derivative function because derivative function is anyhow constant. Okay, so for derivative functions you can see. Now come to a question. Write down. Any other question coming in your mind? Because that derivative point was very good. Any other question right now coming in your mind? Only definition is clear, like this is how we check the behavior. So, and by the behavior you can check which value will be greater. That also is clear now. Now take one example, one question. Determine the values of x for which fx is this. This is simple one because I am just starting it. For which the function is increasing or decreasing. Is this okay, function? Okay, why we are not including, can't we check the monotonicity at x equal to minus 1? The point is that monotonicity can be checked, can be discussed basically on an interval or at a point. So why we are not checking it at x equal to minus 1? It is not defined at x equal to minus 1. It is having value minus infinity. Okay. Now to know the behavior, can you draw this graph? How to check increasing and decreasing behavior of this now? First thing is, for the solution, what we'll do? We have fx value as x minus 2 upon x plus 1. Oh, x not equal to 1. Derivative is how much? So is it so that we are checking the behavior of the function on domain? Is it so? Did you check that? Did you notice that like we are checking increasing decreasing behavior of a function? So we are including domain points only for discussion, or we are checking, we can check monotonicity at every point. Only on? We check differentiability on domain or at all points? Okay, I think let me do a few more questions, then you answer this. What is the derivative? X plus 1 whole square. Simple one it is. So it is 3 by x plus 1 whole square. So what you can say about the derivative now? What you can say about the derivative? It is? It is? It is positive or negative? How many of you are saying it is negative? Or like whatever value? Positive or negative? It can be 0. It can be 0 anywhere. So it is? Why? Because square of any number is always positive and 3 is positive. So whenever like you do such questions now, only first thing you just keep in your mind that you just try to make squares. You just try to make squares in your question, because it will make your question simple. Okay, calculation and thinking will be simple. Like this is square now, this is square. So yes, this is always positive, and 3 we can see this is positive. So I can say this is positive. So it is everywhere positive. So what is the behavior of our function now? So f is increasing on r, yes, r minus 1. We cannot discuss, we are not discussing the monotonicity at -1 point. This is simple one. Okay, let me take now. What about this function now? Think about it and then answer. Fx equal to x5 97 x3 plus under root 77, this much only. I think I should add e. What about this function now? Derivative is? What about this function? Oh, this will be 0, yes. So, derivative also 2, okay, 91x square. What about this function now? This is for all x, or there is some x where it can be negative? What happened? This is how much? E to the power 1? E to the power 1 is? E value is 2.71 something, or 2.71, 2.71 something. So for all x in R I can write for all x in R. Fine. So this is f is, this implies f is increasing. So if I take any value now, 3 is greater than 2, so f of 3, f of 3 will be e into 3 to the 3 cube plus under root 77. Then this value also you can substitute. This will be e 3 2 power 5 plus 97 2 power cube plus, is this okay? This is the value for any value now. These are okay dice question. But why you are why we are like very sure, because this is even power, this is even power, this number is positive, this number is positive, so there is no need to check anything. This is positive, so can it be 0? It can be 0 na? Is this okay saying that this will be greater than 0 always? It should be equal to, but behavior will not change, it is increasing function. So we have to be very particular for what we are writing. Is it fine? Greater than equal to 0. At x equal to 0 this will be 0 na? So we didn't include that point on x for all xr we have said that this will be greater than 0. Is this fine? So what will be the least value now for this case again? What will be the least value? This is good question now. What will be the least value in this case? Because I will use this fact in some other question. Least value in this case. Okay. What others are saying? You are talking about the function, not about the derivative. You are getting confused. How many of you are saying 0 will be the least value or f0 will be the least value? Negative? Yes, negative infinity. Okay. If I ask you the least value of this function, na, then what answer you have given? It will be 0. Okay. So actually you were answering for this function. So least value of f dash is 0. But least value we can discuss only in the case if this is increasing. We haven't checked behavior of this function, na? We don't know it is increasing or decreasing. Suppose I don't know. So suppose this is because if you will differentiate it, na, behavior will get changed. You see, it will be 20e x cube and then 291x. Yes, 291 into 2. So power is 1, power is 3. So if I am just writing if it is this, then you can say that least value will be f0, which is 0. But if it is less than 0, then it will reverse the order. It will reverse the order. So when you answer for which function you are answering, you have to be very particular. So for this function, least value will be minus infinity and then plus infinity. Is it fine? Okay. So now take one question. Write down the question. Find the least value of A such that x square plus ax plus 1 is increasing on 1 to 2. You have to answer what will be the least value of a such that this function is increasing. So what is given to you? How you will start? Fx is x square plus ax plus 1. Interval is 1 is included, and if it is increasing, then what will be the least value? No, it is given actually. It is given that function is increasing. So least value is f of 1. F of 1. F of 1 is how much? Oh, sorry. 2 plus. Okay. And maximum value is f 4 plus 5 plus. But I am not bothering this. I want to know the least value. Now from here, can you answer anything? Minus 2? Sure? Okay, now let me find out the derivative. Derivative will be 2x plus a. Okay, someone said it should be, someone is saying a should be minus 2. Someone is saying. On what fact she is using? Okay, now let me, this is the derivative. Please see here. This is the derivative. Okay, this is the derivative in this interval. Our given condition is saying that f dash x is greater than 0. So, I can't ignore this x now. This x is basically any value between 1 to 2. I can't ignore this value. Fine. So, now f double derivative will be how much? 2. This is also positive. This is also positive. So, derivative is positive means this is increasing. Increasing, I should say. But okay, this is greater than. It can't be 0 now. So, this is strictly nowhere it is 0. So, this function is increasing strictly. So, it means f dash 1 value will be, is the least value? Is the least value. So, f dash x is greater than 0 for all x in this. This derivative is greater than 0 for all x lying between 1 and 2. F dash is also increasing. I checked it. I checked it. Okay, that this is increasing. So, if this is increasing, it means f dash 1 is least value. F dash 1 will also be greater than 0 now. So, f dash 1 is how much? F dash 1. 2 plus a. So, this implies a value should be, so least value basically, least value is basically, least value is how much? A should be, yes, least value is minus 2. Somebody from here, I think in advance, this is good actually if she is too fast in thinking, or what facts she used to answer A should be minus 2. I used my given condition that this function is increasing, so derivative will be greater than 0. I checked its second derivative, which is also again greater than 0. It means my derivative function is also increasing. It means my derivative function least value will be f dash 1. It means 2 plus a is greater than 0, a is greater than minus 2. This fact I used, and I am very strong now to answer that this will be the least value. Somebody used now, who answered a is minus 2? Because if whichever fact she used, if it is applicable for every question, it is okay. But if it is not, the fact she used is not like helping for other questions, then I think you should go to the proper method. Is it fine? Here though you can see everything. Whatever I have written now, that this is the derivative. If it is given, it is increasing, so this will be greater than 0. I checked second derivative also. This is also greater than 0. It means my function is derivative. Function derivative is strictly increasing. And I use this fact, so I can say that this is the least value. Is it fine? So if I give you confusing type of question, then you have to be particular. Okay, let me take some other questions also. Finding A and B values. But you should, I think, speak. Okay, now, what about this function now? Behavior of this function, you will answer me. X plus cos x plus cos x minus a. This is the function. Tell me the behavior of this function now. And values of a also. For what values of a, this function is increasing. Okay, increasing is given. And on R. For what values of a, this function is increasing on R. This you have to answer. This is increasing given. For what values of a, this function is increasing. What is the derivative you are getting? Derivative, this is the derivative, and this is given to be it is given. Sin x values lie between -1 to put up any value now. Put up any value here and just see whether this function is negative or positive. Because we have to answer for a na basically, but this for what values of a, this function is increasing. This function is completely, because sin x range is -1 to 1. So lowest value you can put up -1. What value? +2, greater than 0. If you are putting 1, so it is, so I should say this. Okay, so this is increasing. So what values of a now? Question. This I can say now. I think you can answer now. So values of a are easy to answer. A value is not affecting the derivative. A value is not affecting the derivative and it is given to be greater than equal to 0. So any a value? Yes, any a value. So it is basically R. Any a value na? Any a value? No problem at all. Okay, now is it done? Take second question now. Next question. What about this question now? For what values of a, this function is increasing? Find a for which f is increasing. Try to do it. If you answer this question, it means that you got to know the concept. Concept is simple actually. Concept is not like definition is also simple. For what value of a, this value, this function is increasing. Derivative is how much? Increasing given. So this is the condition you are getting. So it should be 0 to infinity. Somebody is saying, what about others? Who is answering this? Okay. Just think about it a little bit. Somehow answer is not correct. This is simple one. I am giving you 2 minutes to think this question. Minus infinity to 0 is not right answer. No, 0 to infinity. How you are thinking basically? Point is that 3x square value should be greater than equal to a. Then this is the condition. So 3x square value greater than equal to a. So a should be what? Minus infinity to? Okay, I'm just writing your answer. This is basically how you are thinking. Please put up any value now. You are saying na that x for this a value should be any number na. You are saying, okay. I'm just now clearing your point. A value if I take as minus 10, okay, minus. Oh, I'm not taking minus 10. I'm taking 20. A 20. So 3x square greater than equal to 20. This is you are saying now. So if suppose x value I am reducing as 0 to 1, because we are talking in general na. We are talking in general. So put up x0 here. So 0. Here I haven't given any interval. Please think about minus infinity to. Okay, now how? Why you are sure, and how you are sure? Tell me. हाँ.
माइनस में पुट करेंगे तो माइनस में वैल्यू आएगी
हम्म.
और मैम जीरो पुट करेंगे तो मैम लीस्ट वैल्यू जीरो ही आएगी मतलब मैक्सिमम वैल्यू जीरो.
Yes. So 0 value will always be greater than any negative. Okay. So what you did basically, she now actually she got to know because 3x square, a should be less than equal to 3x square. 3x square least value is 0, because otherwise any number you put up, any number, any negative, positive, it will be positive, but at 0 it will be 0. So least value is this, the smallest value. So it means a should be, this implies a should be less than equal to 0. Okay. So if you take this type of a, there will be no problem. Any x will work. Is it fine? So this is how you think. You just write down this question. So any square or any positive power function value, least value is like x to the power 4, x to the power 6 plus x to the power 8, If you are getting such type of equations, they then suppose 8, 100, least value will be 0. For all functions, least value will be 0 because even power, so negative will become positive. There is no problem. So here also least value is 0. So a should be less than equal to the least value. Then it will be always greater than equal to 0. Is it fine?
The power was not positive
Then some other condition they should give, na? Then only we think about that. Then we break up or accordingly we think. So for this question, everything is clear. So nothing is like we don't need another condition or extra conditions. But if like power is odd, then we have to think about that. Then some other extra condition they should put up. Okay, now what about this function now? Find the values of b. Write down the question. Find the values of b for which the function fx equal to sin x minus bx plus c is decreasing plus 1 is decreasing on R. This is also good. Please do it. The same way you have to think. So let me know. Minus infinity to 0. Okay. Please check your calculation again. Because you are saying b values, na? Check for those b values. Like you got some answer. So it means whatever answer you are giving for those values, your derivative should be less than 0. You are saying that, na? And your x value will come from R. Your x value will come from R. For any x R, for any b, derivative should be negative. Okay, check it. Check it. 1 to infinity. Minus 1 to infinity. Any other answer? Now, like I want you to check, please, because in exam you get 4 options. In exam you get four options. So suppose these are your options. Okay. Suppose these are your answers because you are giving me. So because the answer is not like any of the answer is not true. You said 1 to infinity. Take any 2. Take b value 2. Take b value 2 and take any x. Just check. Still your derivative is negative. It should not be. One to infinity, okay. Sure? All are sure. All are, okay, do it. You put up the value? What answer you are getting? No, not B. You are saying, okay, let me know. Dekho. Fx is, please see, fx is sin x minus bx plus 1. It is hardly mattering. F dash is how much? This should be? Take it. This is the condition now? All are getting this condition now? What you did now? I am 100% sure you did that the least value, the biggest value or least value is 1. This is I think what you did. Then b should be greater than or equal to 1. Okay? B should be greater than or equal to 1. So I am taking suppose, okay. Now cos x value will lie between minus 1 and Always. So B value you are saying, B value you are saying as, B value you are saying as 1 to, no wait. I'm putting any actually B value na, 1 to, suppose you are putting it 2 and the range of this will be -1 to 1. Okay, actually you are right. The question is different. B value will be, then what about increasing? This is decreasing actually I'm taking, I just changed the question. For increasing it will be this. Now tell me. Actually I was saying some other question. B will be any B value which is greater than or equal to 1 is working. Sorry, your answer is correct. Because cos x value will lie between -1 and 1. Now what about increasing behavior? What about increasing behavior? B will be how much? B will be how much? Yes, B cos x is greater than equal to B in this case. So B will be, okay, somebody answered, this is okay. Minus 1 to infinity also, you answered na? But who answered then? It's not that some crime you have done, please. You should answer, I think. You should not like feel ashamed and all. -1 to infinity, like my point is, you in your exam, you will get 4 options. Okay. So please check like which option is following the condition. Sometimes it happen that wrong questions or wrong, two options might be correct. Sometimes it happen na. So 2 options might be correct. So it's not that in that case both if suppose 2 options second and third are correct, but in your exam one should be correct. So you either you can take 2 or either you can take third. So in that case your answer will be correct. So you will get marks. Who answered this -1 to infinity? Nothing is wrong. I am just clearing. Cos x value will lie between -1 and 1. So highest value is 1. So highest value is 1. So if your B is basically suppose -3. Suppose B is -3. So this is 1 value and -3 will become, it make, if you put up B -3 it will become positive and we don't want positive. So clear checking na? Clear checking in this interval that this is not the interval. This is not the interval. So this is the interval. What about this question now? What about this question now? B value? Please don't change quickly that it will be ulta. It will be ulta. But somehow you are thinking in a good way. Think about it. Minus infinity to? Minus infinity to? Okay, I'm just putting this -1 value. -1 value is working. -1 will make it +1. +1. And if its value is max to max, it can be -1. Max to max, it can be -1. So -1 plus 1 will become 0. So in everywhere in this interval, we are getting it positive. Is it fine? So B value will be, this is the B value. These are the B values. So B interval is, B belongs to this interval. Good. So it's okay? It's clear? Now take next question. This is something different. And in what way it is different? Write down. You have done intermediate theorem. You have done intermediate theorem. How to, like, for roots we use this theorem for roots. Just write down this question, then I'll. I just rub the board. You must be thinking that your answer was correct and ma'am was like, no, it is not correct, huh? You must be thinking. Sometimes it happens. Actually, I was having increasing values question answer. So I was like that your answer is wrong. So I checked your answer. So fx this has a unique root in. First, I would like to tell you what basically intermediate theorem and how it is applicable and how we apply. Show that the equation this has a unique root in this. Can you find out roots of this equation? You know the method for polynomials? For any power, you know the method? You have done that? Like for quadratic, you know. For quadratic, you know, na? You know. For cube, you know. My question is for polynomials, for any power, you know the method how to find out the roots? You know? Okay, I will not apply that method here. The thing is, what I will do, please see 2-3 things I'll clear. If your function is increasing, okay, if your function is, suppose I'll draw in the 2D to clear you the point. If your function is increasing I am taking, okay. I am not taking non-monotonic functions. I am taking only monotonic, like x to the power 4 function was not monotonic. So this is the function. This is monotonic. All agree? If you have monotonic function, because uniqueness we have to discuss. Uniqueness we have to discuss. So monotonic function I am taking, and this is basically increasing. If your function is increasing or decreasing, if your function is increasing or decreasing, what you do in this interval you have to discuss, na? In this interval you have to discuss. What you do in this interval, this is the least value and this is the maximum value. What you do, just put up 1 in the function and you see the behavior of the function. If it is just suppose this is some value and this is positive, okay, and suppose at 2 this is some value and this is it possible for this case especially? Is this will it happen? What could be the possibility? 1 is less than 2, and I am saying that because I don't know actually. I don't know about this function. I don't know about this function whether this is increasing and decreasing. Just assume the function, this function is increasing. Just assume. Then 100% it will be now. This will be 100%. Now the thing is, this value can be negative and this value can be positive. This possibility could happen now. Either both are positive, either this is less than or this is greater. Other than this, no other possibility can happen. Is this okay? Yeah, to ye, because you want this function I am taking as increasing function. I am assuming it right now. I haven't checked which type of function this is. So 1 less than 2, I am taking it increasing function. So it means f1 will be less than f2. So f1 less than f2 means, and this is increasing also. This is increasing also. So f1 value can be negative and this can be positive, or the next case is both can be positive. This possibility never occur na. This one, third one. Fine. Now just consider this case. If both are positive and your function is increasing, it means there is no root. The function will not vanish in this interval. Is it fine? Because both values are positive, or it can be negative also. Both values can be negative. In this case, so we don't have that possibility. For the root conformation of any function, one value at one point it should be less than 0, and at one point it should be, whichever interval you are taking na, in that interval function should change the sign. In that case you will be very sure that the function has root. root, and for the uniqueness guarantee will be, because it is increasing, so, and value is changing, so it will 100% have unique root. Is it fine? So the condition is your this intermediate theorem basically says, suppose you have 2 points. Now I am talking intermediate function for any function, not monotonic functions I am talking. Suppose you have a and b points. This is fa, this is fb. So intermediate theorem says that if fa is greater than 0 and fb is less than 0, or the other condition could be fa less than 0, fb greater than 0, then we are very sure, we can be very sure that in this interval a to b, your function has at least one root. Is it fine? At least one root. I didn't say about the function. I didn't say the function is increasing, decreasing, or what type of function it is. But if your function, if any function in any interval changes this sign, then there is a surety that that function will vanish at least one point. But if your function, because uniqueness we have to discuss now, if your function is strictly increasing, that in that case it can vanish only once. It can vanish only once. So situation is like, if your fa is, suppose I just draw the function, what type of function it will be for this condition. First condition I'm drawing. Suppose your fa is less than negative, fa is somewhere here negative value, fine, and fb is positive. So I said at least once, so 100% the function could be like this. So how many times it is, because I didn't say anything about increasing, decreasing behavior na. So it is at least once. It is cutting the x-axis at least one time. But if the case I take as strictly increasing, then 100% it will cut only once, because increasing behavior, monotonicity you can't break in that case. So for uniqueness, now you got to know what should I do. I just see the behavior of this function. It should be either decreasing or increasing. Either should be increasing or decreasing to have unique root. Okay, so uniqueness is basically related to monotonicity. Is it fine? So intermediate theorem got to know. If somebody asks you for any polynomial, that how many, but for polynomial actually you know. For polynomial you actually know, like if power is 3, how many roots? 3 powers. If I ask you, give me an interval where this function has roots. Give me interval where in that interval roots of this function should lie. How you will give me that interval? This question also can come. Simple one. If I ask you, give me the interval where the root of this function lies. How you will find out that? Take any value, take any two values where the function changes the value. Okay. So where it will be negative? Any value where it is negative? You can easily give me. At 0 it is positive. At f0 is 1 positive. So positive value I got to know. Now give me the negative value. Minus. Make it little smaller. Minus 2. What about minus 1? Minus 1 it is? Okay, it is positive. So minus 2. It is how much? Minus 8 plus 4 plus 1. So minus 3. So interval is basically which interval? Minus 2 to 0. In this interval, I am sure that at least one root of this function lies. I am very sure. Okay. So can you give me that root? I am giving you surety na, that this function will has 100% one root. So can you give me that root? Minus 2 to minus 1. So minus 1, 0. So there are like infinitely many values. So what about minus 0.5? Are you getting any value where it is 0 right now? 1? But 1 is outside this. 1 is outside this. I just make it, I'm telling you intermediate theorem, and intermediate theorem saying that if you at -2 it is negative, at 0 it is positive. So 100% root is lying between this. If that root could be under root 2, that root could be under root 2 plus under root 3, could be anything. So are you getting any root? 1 is the root of this equation? Yes, 1 is the root of this equation. So f of 1 is how much? F of 1 is how much? 0. So direct, that is direct root. But this equation has how many roots? 3 na. So that those two roots, from those two roots, one root is in this interval. At least one root. So one root is here, lying here. So you can check it. So surety is this. So in this interval 100%. So I have reduced your, like, you just think na, like for what values this will vanish. So I am giving you surety that those values will basically will lie between -2 to 0. So you can put up any value, minus 1.5 or 1 by 2. What about 1 by 2? No. Any value you can put up. But surety I have given you. Okay. So now come to our question. You can note it down. Intermediate theorem helps in finding roots. And the condition is that in that interval function should change sign. I just rub the board. Okay, now come to our question, because I will apply the same fact. First I'll see the behavior of my function. So what about my behavior? What about function's behavior? So function's behavior is what? We have this function. This is positive, derivative is positive or negative? Oh sorry, 5x power 4 minus. So what about this function now? 5x power 4 minus 3, and interval is for all x within the interval 1 to 2. So in this interval, what we can say about our function? Is this increasing or decreasing? It is, because least value, or like one value if you are putting, this is 2. Then 2 when you are putting, this is again greater than 0. Is it fine? And this is polynomial, so continuous. So it will be like continuous, means no breaks. Increasing behavior now. So f dash x is greater than 0. This is increasing function. Now only the thing is, if I'm very sure, or if I have to say that this has unique root, it should change the sign in this interval. f1 is the least value. All agree? So this implies f1 is the least value, and f2 is the maximum value. Tell me both the values. So this implies f is increasing on 1 to 2. So f1 is how much? Okay. f1 is 2. What about f2? f1 is? Okay. f1 is? Somebody said 2, so I was... Okay, you are putting in? f1 is? Yes, it is -3, and f2 is? 25. So f of 1 is less than 0, f of 2 is greater than 0, and this actually which we discussed, if it is increasing then this can be the possibility, and next one was greater than 0. Okay, so this is the case. f1 is this is 1, this is 2, f1 is negative, so it is somewhere here, f2 is somewhere here, 25 also it is given, -3, and it is 25. It is increasing, so it will cut x-axis. I am not bothering that point. So it is increasing. So this is this. It can't come down, na? Okay. So this is the behavior. This is the graph. How many times it is cutting? So we are very sure that this function is increasing. F1 is less than 0, F2 is greater than 0, and and also seeing the increasing behavior of this function, we are very sure that f has unique root in this interval. Is it fine? Fine. Roots fact using this monotonicity. If suppose your function is not monotonic, then you are not sure. Can I now ask you about sin x function? You have noted down? What about sin x function? Sin x graph, you know. Draw the graph. Sin x graph you draw. There the problem is why such condition is not happening. Why we are not getting unique roots within the interval? We have to actually break the interval. We have to break R because sin x function is not monotonic. So this condition, the same uniqueness part we cannot say. Sin x doesn't have unique root on R. Fine, because sin x is not unique on, is not monotonic. Sin x is not monotonic, all agree? So this condition we cannot apply. So sin x is not monotonic on. What about cos x? Same condition it is following. Is it fine? So if your question is like they can give you question type. Question could be like any function and how many roots? How many roots? So first you will check if this function is increasing, then 100% one root only. No other root can lie. Is it fine? And then because we are doing this topic, so from this topic, this type of question is there, then only unique root possibility can happen. Is it fine? First you will check your function should be increasing. Then then if you are getting any interval where the function is changing the sign, then you will say 100% one root. Other root cannot lie. Okay, now tell me what about e to the power x? How many times it is vanishing? How many times it is vanishing? Fx equal to mod x. Oh sorry, e to the power x. How many times, or unique, it could be unique, how many times it is vanishing? How many times it is vanishing? One time, okay. Who is answering? You are too fast. What's your name? Rakhi. Okay, Rakhi, you are saying one time. You are very sure that unique case is occurring. Fine. So it means two things I'll ask you. It means you have got interval in which this function is changing sign. Give me that interval. Okay, Rakhi, give me the graph. Show me the graph. Not visible. This is the graph. This is the graph. Actually, Rakhi is too fast in answering question. Somehow she knows the things, that is not a problem. This is y-axis, Rakhi. Don't laugh. It happens actually. It can happen with everyone. So it is cutting x-axis. Vanishes means you are finding the roots. Just listen. You are finding the roots. Roots means you are finding x values where y is 0. Fx equal to 0 means what? Y 0, na? Fx equal to 0 means y 0. So your point is, ma'am, here it is cutting. But here x is 0, y is not 0. Is it fine? That you can answer that for inverse function. Okay? For the inverse function. So Yes, e to the power minus x. You can draw and then you can see. I think that is this graph, no? That cuts x-axis? Okay. So now tell me, what about this function now? What about others now? 0? Okay. 0, 0. Okay, no points basically. I thought 0. 0 means x is 0. No points are lying in this interval. But this was increasing function. So why we didn't get any root? Why we didn't get any root? Why we didn't get any root? Yes, sign changing is important. Yes, sign changing is important. E to the power x is f dash x and f dash x is, and this is, we have already discussed, e to the power minus infinity is 0, and but we don't discuss, we don't include minus infinity. So this is always positive. So we cannot find any interval or any x value or any x interval where this is changing. So phi f is not changing sign in any interval. Changing sign in any interval. Is it fine now? What about log x function now? Log x is increasing or decreasing? You know the graph also. It is increasing. If I ask you log 2, log 3 value and log 2, so base e you can take. Log 3 will be greater than log 2? So because increasing behavior. How many times it vanishes? Once. Give me the interval now. Give me the interval. Because you know the graph. From graph basically you are saying. Give me the interval where like this is changing the sign. Give me the interval basically where it changes the sign. Give me. You are sure now? One root, unique root. So there must be 100%. There is an interval where it changes the sign 100%. So give me that interval. Where it is changing the sign, you know the log values even. Okay, log 1 is, log 0 is, I am giving you the hint. Log 2 is some positive value. I can say positive value. So I have given you the answer. Answer is on the board. 0 to smaller also you can take. Any interval, but it should change sign in that interval. Any interval, but
We should include an interval in which 1 comes.
one comes.
Because log 1 is 0, so that 1 should come in that.
No, it is not the condition. Condition is at this lower value, function should have either negative value, either negative or positive. If here it is at this lower value, if it is negative, then at the bigger value it should be positive. This is the condition. Changing the sign. Okay. Log 1 0 hardly matters. Log 1 0 hardly matters. You are just basically you are focusing on that value where it is 0. Don't look at that value. I am just asking you how many values basically where this function is vanishing. This is known to function. I am discussing this known to function, very standard function. So condition is that whichever interval you are giving me at this lower value, it should be, if it is negative, then at the bigger value it should be positive. It is changing sign. That's it. Now if at this value it is greater than 0, then at this value it should be, this is the condition. This is the only condition. Is it fine? For root surety, this is the condition. Nothing like this, that I have to include this or that. Nothing. No condition. Basically what you are doing, you are including that root in that interval. No need to do that. I am giving you surety now that if if this condition you are giving, you are checking, then you are very sure that that interval will come in that root will come in that interval. Okay, no need to find the root and then put up that root inside that interval. Then what's the use? Now if you know the roots, there is no point finding the interval. If for any function you know the roots, why you find interval? Very true. If I ask you root of this equation, okay, give me the interval where the roots of this equation lie. I should ask this question? No, na? You know the roots. 1 and minus 1. You can give me any interval. 1 you can lie, 1 lie in this interval. Now you check it. 1 lie in this interval, na? So 100% function should change values. 100% na? See it. 0 at this 0 it is. At 2 it is. It is changing sign, na? And root is lying inside this. For minus 1, I can write the interval minus 3 to minus 2. Minus 1 is here? No. Minus 1 is not here. So it will not change the sign. You just see. Minus 1 is not here. So minus 3, at minus 3 is it? It is? No. X square minus 1. So it is 8. So 2 minus 2 it is 4. So it is not changing the sign, na? So it means root is not in this interval. Is it fine? So root is not here. This is wrong interval. So now I just take simple one. Minus 1 basically I have 2. So minus 2 to 0. Is this fine? Minus 2 to 0. Now minus 2, it is, the value is 3 and 0 it is minus 1. So you got to know. If root will lie and your interval is correct, 100% this condition will hold. Otherwise it will not. And in case your function is increasing, then you can be very sure that function will have one root only. Suppose your function, I am not discussing about this function now. Suppose in this interval your function is increasing. Your function is increasing and this condition you are getting, it means how many roots will lie? One only, unique. Okay? No other root will lie. So I hope this intermediate theorem and this concept is clear. Is it fine? Okay, I rub the board. So don't include that root. We basically checking the roots, so don't include that root. I rub the board. Okay, now one more note basically you can note down. Strictly increasing functions or monotonic functions, strictly, I think I should write monotonic. Monotonic functions always have left limit and right limit at the point of domain. Basically you always discuss na limit. So limit concept is also related. So if your function is monotonic, then left and right will exist. I am just saying will exist. I am not saying that it will be equal or it will be what. But it will exist 100%, and at x equal to plus minus infinity also you can discuss limits for monotonic functions. Otherwise, if the function is monotonic, limit at infinity will be, if your function is increasing, suppose at infinity it will be infinity only. Function is increasing now, so at infinity it will be plus infinity, at minus infinity it will be minus infinity. So you can discuss behavior of whether monotonic functions at such points. At domain points, what will be the limit? Limit will exist 100%. One more thing also, monotonic functions can have finite number of discontinuities. Finite or countable number of discontinuities. If there is any discontinuity will be finite. Okay. So now the next thing is, with the help of this, okay, write down this question now. Any questions? Suppose your function is like this. Breaks actually I'm giving you. You can't say, na, this is not increasing. This is increasing one. How many? But my point is, if function is monotonic, then finite number of discontinuities should be there. Okay? Finite number of, or countable. Countable means what? You can count. No. It's not 3, 4, 4. Like for greatest integer functions, how many, where the function is discontinuous? Where the function is discontinuous? Greatest integer function. At integers, na? Integers are countable, you know, 0, plus minus 1, plus minus 2, plus minus 3. Such types of discontinuity is basically countable. Is it fine? So, a monotonic function can have finite number of or countable number of discontinuities. Now come to this question. If I show that this, how you will do it? Can anyone think? The same concept basically, because we are doing monotonicity. The same concept you have to apply. Can you show me? Anyone? What you will do? Okay, one question I want to ask you. Graphically, how you check whether whether your function is 1 1 or not? Graphically. 1. What x coord? Basically, we draw the graph like xy. We always take 2 points, x and y. At the graphically, I'm asking. You are telling me theoretical definition. Graphically, okay. 2. Yes, that's what I'm asking. So, what you do to check 1 1ness? You draw. What do you do? Theoretical definition is, if your fx is equal to fy, this should imply, this is theoretical definition. Okay. So, and reverse also, if x is not equal to y, then not equal to f of y. This is how you check. This is basically theoretically you check. Y equal to x square is not 1 1. Why it is not 1 1? Actually, graphical method I am asking. How you check? If you have graph and I ask you, or I told you to check 1 1ness, then how you will check? Vertical line you draw or horizontal line you draw? Okay, so this is x square graph. This is x square graph, na? So you are saying this is 1 1. This is cutting ones only. So according to your definition, this is 1 1. Is this 1 1? Fx equal to x square, you are saying 1 not equal to minus 1, but f of 1 is f minus 1. So not 1 1, but according to your definition. So a horizontal line basically we draw, and horizontal line should be once the graph. Then we say that the function is 1 1. Now you just do this. This point is clear. You can write it. Now come to this question now. I have to tell you one thing. What about strictly monotonic functions now? Monotonic functions will be 1 1. Think about it. Any increasing function in any direction you can take, and think about the fact. Every increasing or every monotonic function is 1 1? Can I say that? Both ways. You can draw this graph also. This also you can draw. Check any type of. But it increasing behavior you take, that is the condition. Decreasing also you can take, but with this factor also you can check. This you take, then this you take, and then now answer me, strictly or increasing condition. You are somehow you got the point. What about if I say increasing? I think first you think, I think on this question you are right, your answer is right. I hope I'm getting your point. For one-ness basically we are checking strictly increasing functions. This is strictly increasing, this is strictly, or somewhere it is value is coinciding. For strictly increasing condition is for x greater than y, fx should be greater than fy. This is the condition, na? This is the condition. So for this case, if because I am saying this in general, so if you take this example, this is increasing function, na? Nobody will deny. This is increasing, nobody can deny. But the thing is, problem is that this is not strictly, and the thing is that is this 1 1 now? Where the problem is? Where the problem is? If you take two distinct points, where the problem is that function value is coinciding, okay? So only the point is, if your function is, you can note it down, if your function is strictly increasing or decreasing, your function will be 1 1. Your function will be 1 1. What about ontoness of strictly increasing function? Function will be onto. If it is 1 1, it will be onto also. So it means strictly increasing functions or strictly decreasing functions have inverse. Okay. And one more thing also add on. Inverse function behavior will be the same. Inverse function behavior will be the same. If your function is increasing, strictly increasing, your function behavior, inverse function behavior will be the same. Sometimes such questions also can come, so you can use this property. Come to this question now. How to do this question? Everything is given actually, if you can think. Everything is given. Simple. Sin x is? Okay, sin x is strictly increasing. Draw the graph. You are saying sin x. Sin x value, sin 0 is 0. Oh, sin pi by 2 is? Nowhere it is negative then. Graph is? At 0 it is 0, and then suppose this is pi by 2. So your point is this. You are telling me this much only. Okay, fine. So what I do now? Sin alpha will be? Alpha is less than beta. So fine, good. Then what do I do? Alpha is less than beta. Yes, very good. If I subtract, then how I will be very sure? Minus sin alpha will be greater than minus sin beta. How I add now? Confusion. One is greater, one is less than. How I add? I can't add now this way. Or you have some other like technique? Tell me. Somehow, good point. But I want alpha minus sin alpha. Surely I want. Should be less than beta minus sin beta. According to your information, very good. You have thought in good way. So sin alpha, this is very true. This is given to us. So can I say alpha minus sin alpha, beta minus sin beta less than? Can I subtract like this? Can I? If I take any two numbers like this type, take any two numbers, suppose your interval is, I think this type it is not. You are saying sin alpha less than sin beta. You cannot say na alpha minus sin beta. Now what I am doing is, for sure point basically, if I take this function, if I take this function, if I show this function in this interval is increasing, so sine beta, f of beta will be greater than f alpha. Is this fine? From here, whatever information you were giving, little confusion was there. You agree? Little confusion was there. But in case we show that this function, which is basically the similar function, if we put up alpha minus sine alpha, we are getting, if we are putting beta, we are getting beta minus sine beta. If I show, I have to show it that this is increasing function. I have to show it because sine should not, the function should preserve the order. Then I'll get it. Okay, so what will be the derivative? What will be the derivative? Can I say this is greater than or in this interval basically? What I can say for this derivative in this interval? Greater than 0? It can't be equal to 0 because cos 0 is 1, cos 0 is 1, 0 is not in this interval. So this function is increasing. This function is increasing. So I can simply say, is this fine? So two numbers you can compare using functions. These are basically two numbers, but comparing the numbers by this way was little clumsy and was like surely we were not able to say that this will be true. Are you getting it? So with the help of this function and with the help of monotonicity, we can say that yes, 100% it will be. Okay, so this is greater than 0. So this implies f is increasing function on 0 less than alpha less than beta less than pi by 2. We have alpha less than beta. This implies f of alpha is f beta. This implies alpha minus sine alpha less than. Is it okay? So with the help of function, now we are very sure and we can confirm that this is true. If somebody asks you, check whether this is true or not, that also we can check. Okay, so somebody can ask which one is bigger. I have put up sign here. I just ask you show that. If somebody asks you which number is bigger, so with the help of this function you can check what basically which number is bigger. Is it fine? Done? I can rub. Okay, now next question, write down. Cos x greater than, show it. This is also you have to show. How you will show it now? And the interval is 0 less than x less than pi by 2. Now what you can say, the same in last question, give me some hints. For this question you have any hints? For this question? No hints. So what you will do? You have to show that cos x is greater than this. Fine. So which function you should take? Cos x minus 1 minus. If I show that this is increasing function, if I would be able to show that this function is increasing function, my purpose will be solved. Fine. If it is increasing, then for x less than pi by 2, f of for 0 less than x, 0 less than pi by 2, f of pi by 2 will be greater than f0. Okay. So for these values, I have to show cos x greater than this. I have to show. So ultimately, basically, I have to show that this function is increasing. So let's check the behaviors. So your derivative is sin x plus x cos, okay, yes, cos is minus sin x, cos x minus sin x plus x, so it is, I can't say anything about from here. Can I say? from here, can I say this is this? Can I say? Last question.
Same function we made and
No, we checked functions behavior, a derivative, then we say that this is increasing. It means that we have to follow from here you cannot say anything. Is it fine? Actually, you just mixed up the second question, last previous question. In last question, we checked the derivative. On the basis of derivative, we said that this will be increasing. Is it fine? Directly we cannot say. But the thing is, the previous question which we did, on the basis of that, we can say that this is increasing function. So derivative was, so this is basically now, suppose this is gx, x minus, this is another function I am considering. So g dash x was 1 minus cos x, and this will be greater than 0. So this function is increasing. So this function is increasing. So it means function is greater than derivative is greater than 0. So ultimately we got to know that this is increasing function. So this implies f is increasing function. Is it fine? So f is increasing means this value will be always greater in this interval, whichever value you will take, the cos of f of that will be greater than f of the less value. So it means cos x, this value will be always greater. So this implies cos x is greater than, is it fine? Okay, now take another question. Inverse concept also you got to know. If your function is strictly increasing, it will have inverse. If your function is strictly decreasing, your function will have inverse. Now take, okay, now what about this function? Quickly answer me, okay? Then I'll do the next question. Quickly tell me behavior of this question, this function basically. Quickly tell me what type of function it is. Check it. This is x cube minus 3x square plus 3x minus 100. What type of function is this? And then by the time I'm writing the next question. Monotonic, non-monotonic, what answer you are getting? Non? Okay. How many of you for non-monotonic? You are getting? Okay, fine. What about others? What about, what's your name? Shiva. Okay, yes, Shiva. Shiva, your answer is increasing. Shiva is saying increasing and other is saying non-monotonic. Somebody is saying na. So who is saying? I think I just, derivative is this. Okay, you are saying non-monotonic. Please tell me why you are saying, then I think I just. You are saying कि आपने क्या किया है, minus infinity to 1. Fine, you broke up your you have broken your r real line like this. Why? Okay, fine, then 3, this is what you are getting, this is you are getting now. So you are saying that it will change the, it is changing the behavior. This is what you are saying. Put up any value now. You are saying for suppose 1 less than 0 less than 1 is 0. So at 0 it is, at 0 it is minus 100 x cube. You are saying, what was your point? At 0 it is negative function value. This is what you are checking now. Okay, now at more than 1 it is whatever value give me na, minus at 1 ग्रेटर देन 1 में क्या आप क्या वैल्यू पुटअप कर रहे हो, 2 पुटअप कर रहे हो, ठीक है पुटअप करो, चलो 2 पुटअप कर रहे हो आप, 2 पे क्या वैल्यू आ रही है, आई थिंक इट विल बी नेगेटिव, it will be negative. So now on the basis of this you are checking, you are saying कि ये क्या होगा, non monotonic, you are saying ना, okay. अब आप if you are checking with the derivative property then it is okay. Now I think what you are doing, you are checking function behavior basically in this interval, just check the value. I just took 0 is less than 1, f of 0 should be f of 1 because my from my derivative property, from my derivative fact, I am very clear that it should be increasing. It should be increasing. Now I am applying 0 is less than 1. So f of 0 should be less than f1 na? If it is increasing. If it is decreasing, f of 0 should be greater than f1. That's what I am checking now. I broke up the interval. Now I am checking in those two intervals I am checking the behavior. If it is preserving the order, it is okay. If it is not, then something is wrong. So let me check now. So at 0 it is 100 minus 100 and at 1 it is, so at 1 it is minus 3. All agree? It is preserving the order. So it is increasing behavior. So now why you were saying non-monotonic? Why you were seeing these negative positive values? On the basis of this you check? No, we don't check. Function can have negative value, positive value. You see, I can draw increasing function. You see, this is increasing function. Now. Here the values are negative. All are negative. In this interval, I am not taking any interval. Whichever interval it is, the function is negative, function is positive. But ultimately, the ultimate final conclusion is function is increasing. So we don't see what value, negative value or positive value, we don't see. Definition, two definitions I have given you. What you do in that interval, take any 2 points. If it is preserving the order, it's fine. You will say it is increasing. This is one way to check increasing behavior. Another way is derivative should be greater than 0. So please, there is no connection for the values. There is no connection. There is no connection at all. In the last question, I asked you to show that cos x minus something this. Then okay, cos x greater than this. I asked you this. It means for some interval, I asked you that cos x value should be greater than this value. This I asked you. Negative, positive, I didn't bother. So what I did, I just checked the behavior of the function, and on the basis of behavior of the function, I got to know that the function is increasing. So I used the fact that 0 was less than pi by 2. So cos of 0, whatever f of 0 was less than f of pi by 2. This I checked. Other than that, I didn't see anything. That function will be negative, positive, what will be the function value. But if I am very sure na, function is increasing, and for all values fx is greater than 0. So 100% I can like e to the power x function you can take. E to the power x function if you take, this is always greater than 0 na. Derivative and function both are always greater than 0. For such functions we can say, for such functions, but here there is no connectivity. For negative, if function is negative in this interval, there is no connectivity for non-monotonicity. Is it fine? So to check monotonicity, what you will do, either you find the derivative, or what you do, you just break up the function or the real line in intervals, and you see, like in this interval, take any 2 points, see the behavior of the function. In this interval also, take any 2 points and see the behavior of the function. If it is preserving the order, you will say increasing. If here also it is preserving the order, increasing. That's it. Okay? Don't go with negative positive behavior. Is it fine? I hope it is clear. So this function is increasing function. This function is increasing function. Okay, now do this question. Quickly take the derivative. Quickly take the derivative. In each of the interval we have to check. I am like keen to know your answer in these two intervals. What will be the behavior of the function? X to the power function is fx equal to x to the power 100 plus sin x minus 1. So derivative is 1 by 1 start considering the intervals. 1 by 1 start considering the intervals. In the intervals what you have to check basically? Which method now you want to apply? Please tell me. You want to apply derivative method, or you want to apply that taking any 2 points in this interval, function should preserve the order. I think that is lengthy one. For any 2 points you have to check. So it's like there are many points between 0 and 2 pi by 2. So what do you do? Derivative. You just check the derivative behavior in this interval. So in this interval derivative will be what? Derivative will be positive or negative? It's easy to think. X value is lying between, x value is pi by 2 is how much? 22 by 7. Pi by 2. So 22 by 4. Oh, sorry. 22 by 7. So 14. How much it will be?
11 by 7.
Okay, 11 by 7 I thought. So after dividing something 1.5. So when you will square it, it will be more than 1. It will be more than 1, so it will be positive. It will be positive. Cos x in the interval 0 to pi by 2 positive or negative? Positive. Okay, positive. What about this interval now? Quickly think. Pi by 2 to pi. So pi by 2, this value is 1.5. Pi value is 3.1. So this is positive. X to the power 99 is positive. No problem at all. What about cos x now? Pi by 2 to pi. It is negative. No conclusion at all. Cos. No, I'm not saying it can be negative, but the thing is overall conclusion is not coming now that it is positive, or because this is negative, somehow it is taking negative values, it is taking positive values. Now please see, cos pi is minus 1. Okay, cos pi is minus 1. So confusion is because you have two functions, both are having the different behavior. What I am doing it now, see, x value is lying between this, x to the power 99, all agree greater than 1. Okay, so 100 x to the power 99 will be 100. Cos value, now see, cos value between pi by 2 to pi, it is 0. At pi by 2 it is 0 na, and then at pi it is minus 1. So cos x value is less than minus 1. So basically sin x derivative is No, it is okay. So cos x is less than 1. So 0 less than minus 1 greater than cos x greater than 0. If I add the two values, no, wait a minute. Yes, wait, second. This is not the way we write the interval. I have written, you see, cos x lying between, cos x value is greater than 0 and less than 1. Is it the way we write the interval? Minus 1 less than cos x less than 0. Okay, I was like, oh, what happened? So interval, basically I wrote interval like this. Can you tell me any value in this interval? Can you answer any value? Is this the way we write the interval? Never ever. Okay, please be careful. So cos x is greater than minus 1. Add the two intervals because inequality is same. You can add. So 100 x to the power 99 plus cos x is, and this is greater than 0. Now why I did it? Because I need some solid facts to answer that this will be greater than 0. Okay. So this way you can think. Now what about this interval now? This interval 0 to 1. Please quickly. 0 to 1. X is lying between 0 to 1. So x to the power 99 100% greater than 1. X to the power 99 is 100. This term is positive. What about this now? 0 to 1. Just assume 0 and 1 are in radians because they are in radians. So change at 0, so there is no problem. 0 radian, 0 degree, both are same. 1, you just change 1 radian to in degrees to know in which interval. It will be? No, what will be 1 radian is equal to how many degrees? 50? Yes, good. 50? Something? 57 degree something? How you are getting it? All you know the formula? 180 by? Yes, 180 by 1 radian is equal to 180 by pi. So you can change it. So in first interval it is lying, first quadrant it is lying. So this is positive, this is positive. So in 0 to 1 it is positive. So increasing everywhere, and it is also increasing. What about this now? Minus 1 to 1. What happened? Now in the interval minus 1 to 1 we have to discuss. So in this interval 0 to 1 it is positive. We have checked it. So I will not check on this complete interval. What I'll do, I'll break it. Yes, minus 1 to 0 and then 0 to 1. Here I have checked the behavior. Check the behavior here. Check the behavior here. Minus 1 to 0. Same fact. Your x is lying between minus 1 to, so x square will be, x cube will be again minus 1 to 0, x to the power 99 again minus 1 to 0. So I got to know this value, negative something. What about this value now? Check, change again it in radians and see which quadrant you are getting. It will be which quadrant? Minus 1 to 0. Which quadrant? 0, 0, minus 1, at minus 1 it is? Quickly tell me, this is the last. First, cos of minus x is how much? Cos x, so at minus 1 it is basically minus 57 something. As you changed here. Fourth quadrant. In fourth, cos is positive now. So cos value will be hardly minus 1 to 1. But this value is negative and minus 100. So this is negative in this case. So in half interval it is negative, in half it is positive, increasing, decreasing behavior. So here it is not monotonic. Okay, so write it down. In the last interval -1 to 1, the function is not monotonic. Okay, thank you everyone.